So, when I have to sketch a cubic graph, the lesson is on sketching a cubic graph. When I have to sketch it, I have to know in my mind that the first thing I need is to find the shape. And this one's shape, positive again, has to increase, decrease, increase again. If it was negative, you knew that the other one was true. Second thing that you can find the easiest is will it always have a y-intercept?
Yes.
The nature of the sum going until forever, somewhere it's going to cut through the y-axis. And there I find it by saying put x equal to 0, or just simply looking that the y-intercept is negative 3. It's actually the ax to the third minus bx plus bx plus cx plus d, but you must know it's the d part. Right? You don't have to have it like that. I misspoke just now, but I wasn't actually wrong. Can I say that this is ax to the third minus bx squared plus cx plus d? I can. Right? You have to know how to work with the formula and what it means. Okay, so my y-intercept I've got, can I get some marks if I just did that on a graph showing that form, showing that it goes through negative 3? You should be able to get at least a mark. Then we're needing out, what are we going to do first? X-intercepts. Why do we do x-intercepts first? If two of them are the same, you already have one of your turning points. So then it's a reference. It's not a given or a rule, but it just helps. I feel it helps. So for your x-intercepts, you put y equal to 0. And if I put y equal to 0, to solve this cubic equation, I need to factorize. And the factorization needs a technique which we call Batman or synthetic division. How does synthetic division then work? We say coefficients 1 minus 1 minus 5. And if it happens that one of them is not there, say for instance the 5x wasn't there, then this would have been a 0. You can't have nothing because this represents cubic, square, linear, and the constant number as they are there. So if something's missing, you need a 0 to keep the place. Then this will come right down here, but I can't do anything unless I first get a factor. And how do I get a factor? Various ways that I taught you, but with the calculator. And if you really don't have a calculator, you're a little bit in trouble, but you can get it by going to substitute, because there's the organization or the rule or the arrangement that we still have with the kids is, it won't be the only ones is 7 and 8 and 9. So if you start choosing, you're going to choose forever to substitute something that's going to work. Now I didn't do it, you did, and what's the one that worked? Was the negative 1 work?
Yes.
What does that mean? X plus 1 is a, because this is actually the remainder and factor theorem. When I do division, I get the multiplication of the factors will give me back the original sum. So if I have a factor, then I know that this is the negative 1. I can write there. Now your calculator told you that. Negative 1 is an answer. Did it give you all the answers though? What were all the answers? What were the answers? 1, 3, 3 and?
That's all. And another negative 1.
A negative? Okay. So there were only 2. That would mean to me now, if my calculator told me that one of them has to be a boundary. One of them has to be a turning point as well as the x-intercept. You know this stuff.
Yes, ma'am.
If there were 3 separate ones that your calculator gave you bargain, then you can immediately tell me what those 3 brackets should be. So basically you're cooking it right. Happy on that?
Yes, ma'am.
So now that I could have just as well chosen 3, and both will work to give me what?
0.
A remainder of 0 because it's going to be a factor. Okay. So I'll bring down the 1 there, and then the method is what?
Times.
Times, and get the minus 1 and write it there. Then you add. Then you times and get plus 2. Then you add and get negative 3. Then you time and get 3. And when you add that, you get to 0. If you don't get there to 0, and your calculator told you it must work, in some way you
something.
It missed something or made a calculation error, just check it again. It has to be. This says the remainder is 0 if the factor goes in. So, what did I just find here? That instead of 0 equal to, that answer, I'm breaking it up into factors. The first factor being the linear one with x plus 1. The second factor reading
X
x
squared
squared
minus 2x minus 3.
Fantastic. Which then in general is usually factorizable again with your James Bond method of factorizing. Whichever way you choose, the x is going to be a plus 1 and a minus 3. If you know your James Bond technique, let's do it again for all time's sake. 1 times 1, 1 times 3. Cross multiply, to get to negative 2, your signs must be negative plus like that. Move your signs to the top, and there are your two brackets in James Bond spy language, which only us understand. So the two brackets are x plus 1, x minus 3, and it doesn't matter if the stuff is turned around. So the full factorization of that original function f has got those three brackets. So you needed to find a new technique with the remainder and factor theorem to be able to find factors. If this doesn't factorize, what do you do then?
You do
The formula. Because this still means if two things are timed and the answer is 0, this is 0, so x is negative 1, and that is also equal to 0. If there are no factors, then you do it with the formula, and your answer will be something like 1,35, 6,21, whatever. In other words, not rational, but irrational that you round off. And that's perfectly fine if it doesn't have. And maybe it doesn't have real numbers, because then it means this doesn't have an answer. So there's only one factor. How does a graph like that look? Somewhere it just cuts the x-axis once. That's what it's going to be. So it can happen. You must know the stuff that can happen. You can have 3 x-intercepts, you can have 2. Then normally the one is the bouncing, and it can only have 1, which means it only cuts through one place, and the turning point somewhere else, or the bottom, it doesn't matter, but it only cuts once. Happy on that?
Yes, ma'am.
So my x-intercepts are -1 or 3. And since I can now see that that's the double one, I know that this is my turning point. After getting the y-intercepts and the x-intercepts, I then need to find the turning point. Finding the turning point, that's the actual reason why this is in calculus. The only reason, because x-intercepts and factorization is still new work, but it's not calculus. You don't need calculus to do it, you need some other technique to do it. Okay? So when I want to go and get my turning points, I need to know a fact. That the gradient is equal to 0 wherever the graph turns. So in the turning point, the gradient is 0. Wherever it turns, the gradient is 0. But what is gradient? You find gradient with derivative. That in itself could be worth a mark for knowing that the gradient is 0 in the turning point. Find the gradient, find the derivative, and that is 3x squared minus 2x minus 5, which should be second nature to you now. Exponent times coefficient, take away 1. Exponent times coefficient, take away 1. Are you with me? When we did those differentiation rules, there were roots in them, there were denominators in them. Is that going to happen in a cubic graph? So this will always be kind of like a straightforward differentiation rules, exponent times coefficient. You don't need to do much with it. Okay. I was thinking, could they have started off the sum and said, listen, go sketch for me fx, but they give it to you like this. What are they doing? They're giving you the, because if you want the x-intercept, you just put y equal to 0. So they're missing all this work, and you were so right and ready for Batman. It's not always there, but if it is and you don't know what to do, then there's a problem. Okay? So be on the lookout. Sometimes this is a help, right? And I can immediately find my x-intercepts. But to find the turning point, to be able to do the derivative, I can't work with this. You have to then distribute, time it all out. Get to this answer so that you can differentiate and get back to your gradient. You see all the scenarios that's going to come. Okay. So now that I'm there, I need to go find the factors, all the factors.
Yes.
Okay, so if I do it old school, 1 times 3 and 1 times 5, for the 3 and the 5, remember the 3 at the top, the 5 at the bottom, cross multiply to give me -2, that'll be plus minus, because that adds up to -2. So the brackets must be x plus 1 and 3x minus 5 equal to 0. So the 1x value of the one turning point will be -1. Aha! It has to correlate, otherwise I'm making a mistake. So that's the one I was looking for. So immediately I know that the one turning point is -1, 0. Because it's also an x-intercept. The other one I don't know. The other one is for x equal to 5/3. But do I know the y value? How do you find it? Substitute back into the original sum. So that's going to mean, understand function notation? Go and substitute 5/3 in the place of x function notation and giving you an answer. Please, has somebody got that answer for me? So substituting the 5/3 everywhere and giving me an answer. Because 5/3 is a bracket fraction, so this is also going to probably be a fraction, and it can even be a very small or very large fraction with a comma, what that you're going to have to round off. So it doesn't always have to be a whole number or an integer. Right, answer please? -3,93. Round it off to 2 decimals unless the sum says otherwise. Because I need to go sketch this. So I would also like that rather to be, instead of 5/3, maybe be 1,67. Do you agree? Because I want to go sketch this thing. So I need to know that the one turning point is there, 1,67, and
the correct answer, ma'am,
yeah,
is -9,48.
this one. 48.
Yes.
All right. So let's see if we can sketch this thing, because we should be able to sketch it now. If we go for the sketch, we have our y-intercept of -3. Please remember this is a sketch graph, so it's not according to scale. And even if I've got an answer of 20 and 30 and 50 here, I'm not worried. I'll just say there's 50. And it doesn't have to be in scale and in proportion to each other. So we need the y equal to -1. We've got x is equal to -3. -1, look at my sketch. I'm feeling a little uneasy. Are you with me? But the other side will then be for x is equal to 3. And which one is the turning point? The -1. So Ma'am has told you some sort of a technique that I'm going to show myself. That's not only an x-intercept, it's also a bounce, a turning point. So then I still need to go find -1 and 0, which I've just now indicated. And the other one is 1,67, which should be right about here, and -9. So I'm just saying, let's not squash it onto the graphs and into the axes. Just make it legible so I can see this is 1,67 and -9,48. No measuring, being accurate with it. But that is also a turning point. So if you look at the sketch and you know it must turn there and turn there, the only way it can go with a shape that starts left-hand side bottom and goes up is how? Can you see it? It has to go turn there, go through the y-intercept, turn there again. My sketch is a little skew. And please remember what I indicated to you previously. This is not symmetrical. Not like a parabola that's symmetrical around the y, the turning point. You get to your x-intercepts that are the same. It's not. It's not equally far or equidistant from 1,67 to the x-intercept there and to the x-intercept there. It's not. Okay, so no symmetry here. Could I then ask you for an axis of symmetry in the QE graph? Because there won't be one. I ask you for axis of symmetry with the parabola, because there's two. Parabola. Hyperbola, there's two. Parabola, there's one, round the turning point. What else? Exponential graph, axis of symmetry, there's none. Okay, but asymptotes. Hyperbola, there's two. Exponential, there's one. Parabola doesn't have asymptotes, and no asymptotes here as well. Just going to a little bit of revision. Is all of that going to be in your June exam? Okay, knowing all of that stuff. Right, let's carry on with the same sum, because that was your homework, and if they ask it, and I haven't seen it in a long time, if they do ask it like this could be a 15, 17 mark question. Because this is about 4 or 5 marks. This is about 3, 4, 5 marks. Your y-intercept, your shape on the graph, are you with me? Anywhere from 12, 13 up to 15, 17 marks. That used to be the case. So then they saw it's a lot of marks, and we only have 150, so let's maybe give them the x-intercepts, giving them that in the brackets, or I'm helping you with some sort of a thing. There are still some stuff to come, okay? Now we need to get to the point of inflection. Now I haven't spoken about that. If you had to do this sketch, you would get full marks for it, but from today now, I would like you to also put in the point of inflection. Now the point of inflection is where concavity changes, all these words. All right, so this I'm going to have to teach you is concave downwards, or concave to the bottom if you want. If you look at a parabola, parabolas like this are concave downwards. If you look at it like that, parabolas are concave upwards. It's just smiley or it's frowny. But this is concave down and concave up, and it changes somewhere from being concave down to concave up. And that point is exactly in the middle of those two turning points. The x value is exactly in the middle, somewhere here, because this is 1 comma and this is, so somewhere here, it's going to change concavity from being concave down to being concave up. And I'm teaching this to you now. That is where the concavity changes, and it's exactly in the middle of -1.
Solve 139 plus 14. I praise you for giving and wonderfully made. Wonderful are your works.
Right, so we're talking about the point of inflection, which will always be exactly between those two x's, and I haven't said it yet, in exactly between the two y values as well. This y value being 0, this y value being negative 9,48. So if it makes sense, you don't have to write it like this, but you take the two x values and you add them together and get half of that. What's the answer, please? And exactly the same with the y's. Add them together, get the half of that, would be negative something there, and this should be positive something. Please give me an answer. So right in the middle, there you get your point of inflection. First answer, please. 335. 335. So it's going to be 3, 4, and the other one? Am I right? Okay, so that means that is the point where what happens? Concavity changes, because it's going to come into questions now. The fact that the graph was concave down and changed into concave up. So there's only two things that can happen. If this was your graph, concavity downwards changes into concavity upwards. If it was a graph that we haven't had yet, where concavity up changes into concavity down, you're also going to have the point of inflection, and that's where the concavity changes. But that's not it. Because sometimes you're not going to sketch it like this and actually work out the turning points. So I have to teach you that for concavity changing, the point of inflection or the inflection point, you're going to do the following. And what's that? And now I have taken away made my sketch. What was the first derivative, please? 3x squared.
minus 2x minus 5.
Okay? So if that was my f dash, what is going to be the double derivative?
6x minus 2.
Okay? But equal to 0 only for the point of inflection. We haven't had this at all, right? So then what does that mean? 6x equals to 2x is equal to? And remember, why is it exact? Because we rounded that jolly thing off. That's why it's not so precisely exact. Do you see it? But a third is 0.33. A little bit of a difference. And if you work with 0.33 and this one then as well, if you don't take the 0.33, you can just put it back into the original sum to find the corresponding y. So there's two totally different ways of doing it. If I just give you an equation and ask you for the point of inflection, no sketches, no nothing, how do you find point of inflection from today? Double derivative equal to 0 will give you the x. And if I got the x, substitute to get the y. Right.